Good morning, everyone. Welcome to Software Engineering. I'm Zhang Shuang from Software College, Northeastern University. Today, we are going to learn software lifecycle models. Software lifecycle model is the series of steps through which the product progresses. That means different software products may experience different lifecycle modules. The reason is that different software lifecycle will be different according to their own size or their type or the development environment or technique. So that means each software system should choose a suitable model. So what are the software lifecycle models? Actually, there's quite some software lifecycle models. Due to the limitation of time, we are going to learn build and fix model is also called code and fix model, waterfall model, rapid prototyping model, incremental model, synchronize and stabilize model, Sparial model, and 14 model. First, build and fix model. Let's look at the diagram on the right side. The first step is just to build the first version of the software system and modify it until the client is satisfied. So you can see the loop here, modify until the client is satisfied. Well, we find that there are no specification and no design. So surely the target software system will be totally unsatisfactory. Well, this model may need a game plan, phases, milestones, and so on. So you can find that build and fix model is really not a good one. We should try to avoid the build and fix model for our target software system. Second, waterfall model. So let's read the diagram first. The first phase of waterfall model is requirements phase, and next specification phase, design phase, implementation, integration, maintenance, and retirement. And we find that this model is characterized by the feedback loops. You find that there are feedback loops from one phase to the previous phase. That's because maybe during some phase, the developers will find there are some problems that's caused in the previous phase. So they will have to feedback to the previous phase. So that's why feedback loops. And another character of waterfall model is documentation. That means all the phases are driven by documentation. That means only when the documents of the previous phase has been completed can the next phase begin. So that means the documents will be very good, because documents is taken great importance. And it is disciplined approach. Well, the disadvantages of this model is that the delivered product may not meet client's needs because it cannot handle the problem of requirement changing. And when the target software system is too big, or too complex, and then waterfall model will fail. But it has been very successful before 1980s. It is widely used before 1980s. The third one, rapid prototype module. That means the developers will use rapid prototype to replace the phase of requirements. A rapid prototype reflects the functionality to be provided to the future users, such as input screen and reports. So that means something can see and touch. And then the developers will let the client and the future users to interact and experience with it. So in this way, it is very likely that the developers will determine the clients and the users' real needs. So that means the requirements will be very clear and complete and correct. So we find that there are no feedback loops. That is because the requirements is good enough and the developers won't get problem in the following phases. So no feedback loops will be needed. The strength of prototyping model is that it ensures the delivered product meets the client's real needs. We must admit that it is not yet proven beyond any doubt. And we should always remember that rapid prototyping may replace the specification phase, but never the design phase. Next one, incremental model. This diagram tells us that the first phase is requirement phase, and the second is specification phase. It's just the same with the previous modules. But the third phase is architecture design. And then the system is divided into builds. And then for each build, perform detailed design, implementation, and integration, and test, and deliver to client. The advantages of incremental model is, first, the complete product is divided into builds, and the developer delivers the product build by build. So in this way, it reduces the traumatic effect of imposing a completely new product on the client organization. And also from the client's financial viewpoint, purchase the delivery requires no large capital outlay. These are the advantages of incremental model. In fact, for some projects, incremental model is really a good choice. When the target software system is too big, and to try to develop and deliver the whole system at one time will be a great risk for both the client and the software organization. So incremental model will be a good choice for both. But the software organization must be very careful with incremental model, because if the process is not handled correctly, and maybe it will change into build and fix danger. And it also requires very high skills of technical and management for the software organization. So that means not all software organizations can do a good job for incremental model. Next, synchronize and stabilize model. This model is really something unique for Microsoft. And we know that Microsoft only delivers some software product. That means they don't have a certain customer, but they have quite some potential customers. So during their requirements phase and analysis phase, developers will interview potential customers. And then they will draw up specifications for the target software system. And then they will divide the project into 3 or 4 builds. And each build is carried out by small teams working in parallel. At the end of the day, each build will be test and debug. That is called synchronize. And at the end of the build will be frozen. That means stabilize the build. That means no change for the build anymore. Because the build is supposed to be completed and tested correctly. So now it's fine. So no touch anymore. The strength of this model is that future users' needs are met, and it ensures that the components can be successfully integrated. Well, the truth is that this module is not widely used other than at Microsoft. So this is synchronized and stabilized model. Next, Sparial Model. We find that in this diagram, at the beginning of each phase, risk analysis will take place. So that means before the beginning of each phase, the target system should be analyzed from the point of view of risk. Is it possible, is it reasonable to achieve the target software system or not? So we find that this model may be understood in this way. It's just plus risk analysis preceding each phase of waterfall model. And if any risk was found to be unresolved, and the project will be immediately terminated to avoid bigger risk, bigger loss. So this diagram tells us that from the beginning of the project, risk analysis is to be done first. Well, if it's okay, and then rapid prototype, and after this phase, the work should be verified. Okay? And then go to the next phase, and still risk analysis first. Now, after the risk analysis, specification and verify, and the next phase, risk analysis, design and verify, and so on. So you'll find that risk analysis will take place before every phase. And once risk is found too big or cannot be solved, and then the whole project should be terminated. Well, the strength is that this model is risk-driven, and it can avoid big loss, big risk, or big waste of investment and work. Well, we must understand that this model is applicable for only large-scale software and internal software. Let's suppose this target software is based on contract, and even though some risk have been found, the software system cannot be terminated because the contract won't allow it, right? But if this software system is just internal, so surely it will be okay to just terminate it. If some software is too large, that means too big a risk, and then it will be worthy to take this module to try to avoid more loss. Well, this module also requires developers to be competent in risk analysis and risk resolution. So we find that this Sparial model is not suitable for every software organization, and it is not suitable for any projects. For TAM model, well, this diagram is really different from previous ones. The previous ones should be read from up to down, but this one should be read from bottom to up. The first phase is requirement phase, and the second is object-oriented analysis phase, and object-oriented design phase, implementation, integration, and maintenance. We find that some phases are overlapped. We find that here, some phases are overlapped. Overlap means parallelism. So that means sometimes the work during different phases may be taken in parallel. It's not must be linear. You see these arrows. These arrows means iteration. Iteration is really necessary because it is the character of object-oriented paradigm. Maintenance phase. We find that maintenance is just a small circle. That means using this model, the target software will be more satisfactory, and then less maintenance will be needed. So that's why the circle is smaller. This model is also called object-oriented software lifecycle. So actually, most of the parts that we learned in our course just follow this model. So you will find that in the previous chapters, we have learned requirement phase, object-oriented analysis phase, and object-oriented design phase, implementation and integration, right? Okay, so this is for TAME model. From previous introduction, we find that different software lifecycle models has its own strengths and also its own weaknesses. So how to choose a suitable software lifecycle model for our target software system? The criteria will include the organization, its management, its employees, and the nature of the product. So that means the skills, the technical skills, the management skills, and development skills, and the target software system's own characters. Okay? So all such kind of things together will decide the suitable software lifecycle model. So that's why we said that different projects and different software organizations may choose different software lifecycle models. So maybe you will ask, can you tell us which software lifecycle model is the best one? The answer is that there's no the best one, because it depends on the organization, the employees, and the software itself. So the best suggestion is that mix and match lifecycle model. So that means you should try your best to take the most advantage of some software lifecycle models and try to avoid the model's weaknesses. Okay? So mix and match them to get the most suitable software lifecycle for your own software organization and your target software project. At last, we must always remember that there's no planning phase, no testing phase, and no documentation phase. Actually, we find that during each phase, we have talked about the planning and the testing and documentation. So no need for just separate phases for such kind of things. And we must also understand these are ongoing constant processes. And nowadays, we get so many software lifecycle models, and surely in the future, we'll get more software lifecycle models. We can't tell which is the best one. And the only thing that we can do is just try to choose the most suitable software lifecycle model for your project, for your target software. Okay, so much for software lifecycle models.